Question number 6 says, in finance, one example of a derivative is a financial asset whose value is determined or derived from a bundle of various assets, such as mortgages. Suppose a randomly selected mortgage in a certain bundle has a probability of 20% of default. Complete parts A through D below. So what is the probability that a randomly selected mortgage will not default, that is, pay off? So there's a 20% chance that it will default. The opposite of that, okay, to make the 100%, if there's a 20% chance of default, 1 minus the probability that we don't default, that we do default gives us a chance we don't default. So that's going to be 0.80. So that we pay off. So it's going to be 0.80. All right. B, what is the probability that a bundle of 5 randomly selected mortgages will not default? Okay, so let's spell this out. Probability of default. So we're going to say probability of D. I'm going to use D to be default. It's going to be 0.20. The probability that it will not default, so I'm going to say D complement, is going to be 0.80. So we can keep track of these. B says we got 5 randomly selected, will not default, assuming any one being paid off is independent of the others. Okay, so what is the probability that a bundle of 5 mortgages will not default? So we want 5 of them to not default. So this right here. The probability that all 5 of them being independent would be, I'm just going to say, the probability that will not default, 5 of them, is going to be 0.8 raised to the 5th power, or that 0.80 times itself 5 times because they're independent. So if I do 0.8 raised to the 5th, that gives me 4 decimal places, 3277 when we round, 3277. What is the probability that the derivative from part B becomes worthless? So that is at least one of the mortgages defaults. So one or more default is the same as none of them, 1 minus none of them default. So if I take the same probability that we just did, which this was 0.3277, at least one default say D greater than or equal to 1, that's the same thing as 1 minus none of them default, symbolic wise, and we're dealing with 5 of them, so it's going to be 1 minus that 0.3277. That will give us 0.6723. This is the probability that at least one will default. It's 1 minus none of them default. All right, and then D, in part B, we made the assumption that the likelihood of default is independent. Is this a reasonable assumption? Explain. So, unless we know these people have some relationship and they have bad credit, or they've defaulted before, we know something about their history, I think it is okay to assume that they're independent. So yes, national economic conditions such as recession will impact all mortgages. So if one mortgage defaults, the likelihood of a second default increases. In part B, we made the assumption the likelihood of independent. Is this a reasonable assumption? So I say yes. I guess this would be no if this is the case, because if we do go into a recession, one defaulting probably will affect all of them defaulting, because we're all in a recession and everybody's struggling. So that's what this is saying. So the assumption of independence would not be good in this scenario where we have a recession. They will impact all the mortgages. In one default, the likelihood of a second defaulting increases, does not change. Saying increases if they're dependent.